when it comes to multiplying two graphs, which is what that means, f of x times g of x, when they put together, it means you're multiplying the two graphs. Let's say this is my f of x and this is your g of x. We need to multiply it. The first thing that you always want to do is draw a horizontal asymptote at y equals to 1. And there's a reason why. Okay? As well as minus 1. Okay? Do that. Because, girls, at that point, the value is y equals to 1, yeah?
Yes.
1 times anything is... What?
That was the number.
1 times anything is 1. 1 times anything is anything. Yeah? So if I just extend this a bit, right? So 1 times anything is that anything. Is that in the same line? Yeah. Does that make sense? So that's my first point, right? Secondly, the number that I like to multiply are the actual numbers on the y-axis. So 4 times minus 2. Yeah. So our next point when I multiply those two is at minus 8. Okay? Now, thirdly, girls? What are you going to say to this one? 0. 0 times anything is 0, not anything. Yeah? So, girls, 0 is here. So, this is the point on the graph where y equals to 0. So, 0 times anything is 0. Yeah? So, that's always going to be the case. Now, it's kind of not enough. Let's do a few more, or just one more. Girls, here, let's say that value there. That's a huge positive number. Let's just say, yeah? If you have a huge positive number, and then let's see what's related to that, and then we have a huge negative number, you get a huge negative number, or even bigger, yeah? So let's just say, I won't say huge. Big positive multiplied by big negative equals to bigger negative, yes? So obviously it's going to be like somewhere all the way down there, yeah? So it's actually out of scale. Can I rub it off if I... No, that's on record. I don't want to do that. Alright, let's say it's like all the way over there. So, girls, imagine there's a dot there. Girls, if I actually join the dots, it's going to look like this. Oh my gosh.
That's me when I do graphs.
It's actually a cubic. It's actually a cubic. Okay, out of scale, it's actually like this.
What happened to your asymptote? Just went over.
The asymptote, the value of 1s is just used to help us easily multiply anything with 1. Just to spot out where the 1s are. It's not an asymptote, no. It's a guideline.
It never happened.
Yeah.
You do the same thing for the bottom asymptote as well.
Oh, unless they were both into...
Yeah, so you look, I didn't use a minus 1. Let's say here, this is minus 1, right? Minus 1 times anything is minus of that anything.
Wait.
So let's say this is, I don't know, let's say this is 7, right? 7 times minus 1 is minus 7, which confirms right there. Yeah? So girls, the 1 and the minus 1, they're not asymptotes. They're guidelines to help us what to multiply 1s by.
Well, the only point that...
So girls, do we get the point? So one more thing. Minus 1 times anything is what?
One of the...
Minus anything. Okay? So girls, another good pointer. In the exam, if you wanted to confirm that your final answer is going to be a cubic graph, girls, it makes sense because, girls, what type of graph am I multiplying? What's this? Parabola is x squared, isn't it? Times by a straight line. What does the power of x have? Sorry, what does the power of straight line have? Just x. And what's that? Yeah, which is a cubic graph. So if you're ever not sure what type of graph you should be getting in the end, look at the graphs. You're doing a parabola times a straight line gives you a cubic. This time I'll do it in blue. So girls, once again, the first step, like I said, is to draw So,
Would you get marked down if you left it? Should you?
no, you don't get marked down, but it just makes it convenient.
No, but
No, it's not part of your working out.
yeah, but it's an actual asymptote if you leave it.
No. If you left in your final answer,
Yeah.
just because you have those zones doesn't mean you're going to get marked down.
Okay.
Yeah, it's fine. All right, girls. Now, let's do it. So, girls, usually for me, the first step I like to do is actually that one because 0 times anything is 0. That's actually the easiest. So, where 0 is basically your x-intercepts. Yeah, x-intercepts are where y equals to 0 is. So on the x-intercepts, it's going to be a point on those graphs for sure. Because like I said, 0 times anything is 0. 0 times anything is 0. 0 times anything is 0. So it has to go through the x-intercept points. That's your first data. You with me? Second point, now let's do 1 times anything. So looking at this line, we can see that it's here and it's here. So 1 times anything is that minus anything. Yeah? So this is like me saying, yeah, it's like me saying, what's 1 times minus 5? Minus 5. Same thing here. 1 times wherever the next graph is, you have to keep going. Let's just say it there. 1 times anything is anything right there. Okay? Now let's do, what haven't I done? Let's do minus 1 times anything. So minus 1 is here. So that's here and here. Okay? So minus 1 times anything. Let's call that, I don't know, let's just say that's minus 6, right? What's minus 1 times minus 6? Plus 6. So I'm going to take that much and I'm going to flip it that much, so it should be here. Does that make sense? So when you do minus 1 times anything, it becomes the positive version of that reflected on the other side. Same thing here. Minus 1 times, let's call that minus 9. What's minus 1 times minus 9? 9. So basically, you're taking that much reflected here. So I'll try to draw as long a line as possible. Is that about right? Yeah. Okay.
So there's 2 other minus 1.
Oh, is there one more?
There's 2 more.
Okay. I want to stop there. The other point I want to show you is, girls, when you have, sorry, I don't want to put a dot. It's not part of the final answer. So at that point, so let's say that's, I don't know, 1, 2. Let's say that's minus 3. That's like you doing minus 3 times minus 3. Becomes 9. So positive 9.
Right.
There?
Yeah.
Yeah, okay.
Minus 9.
Okay. Minus times minus becomes huge positive number of that. So, yeah, I'm not going to do that. It's like out of scale. Yeah? Girls, you know how we have right now parabola times parabola? So in terms of x power, this is x squared times x squared, yeah? So x4 graph either looks like this or this. So we are expected to sketch that using the dots we have. So if I was to do it, it looks like this. Oh, it's supposed to go all the way down. I'll try to do it darker in purple now. Okay? So it's basically this. Alright? Okay.